Welcome to our next complex numbers video, our second video on polar form. Now we know complex numbers can be written in the form of a plus or minus bi, and we call it rectangular form. Another form we introduced last video was polar form, r cis theta. Let's go through some scenarios. We know this complex number, written in rectangular form, is 4 plus 3i. In polar form, we can work out the modulus 5 and the argument 36.9 degrees, or if you prefer to work in radians, 0.6435, and write it as 5 cis 36.9, or in radians. What about this complex number? Sitting on the imaginary axis, so no real bits and 5 imaginary, we call it purely imaginary, and in polar form we'd write it as 5 cis 90 degrees, or remember 90 can be written as pi over 2 radians. We move into the second quadrant, and we could write this as minus 5 real plus 4 imaginary, or we could write it as 6.4 cis 141.3 degrees, or again, work in radians if you prefer. But notice the right-angled triangle we've created. It's probably easier to work out this angle, 38.7 degrees, and subtract it from 180 to work out the argument. When we have complex numbers on the real axis here, we just say it's a purely real because z is equal to -4. And in polar form, we'd say 4 cis 180 degrees, or remember pi is equal to 180 in radians. If we move into this quadrant here, for rectangular, we'd say -5 real minus 3 imaginary, and we would then work out the modulus and the argument. It's probably easier when you're working out the argument to work out this angle of 31 degrees with your trigonometry and then add it on to the 180 to make 211 degrees. But notice when we get to this quadrant, we can actually, instead of rotating anti-clockwise and going larger than 180, we can now actually rotate clockwise and make it smaller than 180. So when we rotate clockwise to get 149 degrees, we're actually going to have to put a negative sign in the brackets because the negative means rotating clockwise. If we have complex numbers sitting here on the imaginary line again, it's purely imaginary, so z is equal to -3i, and we have in the polar form 3 cis 270 degrees, or again, we could work clockwise and make it -90 degrees. So just be mindful, anti-clockwise is positive, clockwise is negative angle. When we move into our fourth quadrant, this complex number has a rectangular form of 3 minus 3i, but in polar form we work out the modulus of 4.2, so it would be 4.2 cis 315 degrees. But again, we could work in a negative direction and make it -45 degrees. We could also work in radians, again, any time for any of these complex numbers. And finally, if we pop back to the real axis again here, this is 5 plus 0i, no imaginary bits, it's purely real. And in polar form, we'd say 5 cis 0, because we're not rotating anywhere. Second thing I'd like to do in this video is chat about how we change polar form back into rectangular form. And let's talk about what cis actually means. So let's take 4.47 cis 26.6 degrees and turn it back into 4 plus 2i. To do that, you need to know that c represents cosine. So we're going to go 4.47 times the cosine of 26.6 degrees. Then we put a plus. The I is the I, and then we multiply the I by 4.47 times sine of 26.6 degrees. That's what the S means. Now we grab our calculator to work out the first bit, the real component, and we set our calculator up into degrees, and it's close enough to 4 because of a little bit of rounding. So we're going to write down 4, and then we put the I times, and we work out 4.47 times sine of 26, that's close enough to 2. So we can simplify it to 4 plus 2i. Right, thanks so much for watching.